Hey guys, welcome back to the channel. Today I want to talk about building your own set of adjustable end links or drop links. These will be monoball styles, so not your kind of not OEM style or like with your typical kind of like tie rod end with grease boot and all that stuff. These would be more like for motorsport applications. Um, First and foremost, this video will be in two parts. I think the first part of the video is going to cover kind of the selection of parts, the selection of rod ends, how we determine which rod ends to buy, and all the things we're going to need to build it. And then in the second part of the video, we'll actually go out into the garage and make a set. And that's an effort to try to keep these videos from getting too long. I know I have a tendency to make really long videos, so we'll break it up for you guys, and hopefully that helps. Um, the other thing here is that I want you guys to know that I'm not like an engineer or anything like that. I've done my research and I've tried my best, but this video is really just for educational purposes. Please, I'm not liable for anything that you make, do, or what happens with your car, or anything associated with this video. Okay, so um, let's talk about an endlink really quick, just so we understand what it is. An endlink connects your control arm. So on a 2015 Subaru, this would be the control arm down here. This kind of crusty looking thing that's made out of aluminum. It connects your control arm all the way, it goes up here, to your sway bar. And so why is that? A sway bar or an anti-roll bar is there to help a car from rolling once you enter a corner. And that happens via the end links, right? So as you roll into a corner, one side of the car is going to roll and get closer to the control arm as the suspension compresses, and the other side of the car is going to roll away from the control arm as the suspension kind of uncompresses or expands. And as that happens, because the control arms and the sway bars are connected, as you roll into the control arm, it's going to push up onto the sway bar, and simultaneously on the other side, as you roll away from the control arm, it's going to pull on that sway bar or anti-roll bar. And you can think of the sway bar or as anti-roll bar as just a spring. So as you push into it, it's going to resist that compression, and as you pull on it, it's going to resist that expansion, right? Essentially, the anti-roll bar is a spring that's been just pulled straight into a bar. The first reason why you might want to be able to change the overall length of your end link might be because you've lowered your car, and so the control arms have gone up a little bit, and because they've gone up, they've pushed, the end links now are pushing up on the sway bar, and the sway bar is rotated up a little bit. That way, because you can't adjust your end link length, so it's just going to simply push and rotate the bar up. And maybe when that happens, you have some type of packaging problem. Like a common one might be it runs into your tie rods, right? So now you've lowered your car, sway bars rotate up, and it hits the tie rods. Well, you can't have that happening. So a solution might be to chop a certain amount of end link off to pull the bar back down, so you have enough clearance. And maybe depending on the different heights that you have, you need an end link that you can adjust so that you have the proper amount of clearance. The other reason, which I think is sort of the more common reason, or the more motorsports reason, is because you're corner balancing a car. So you ideally want the bar to be neutral, meaning the control arm on either end is not pulling or pushing on the bar, and so it's not providing any type of force. Well, when you corner balance a car, and if you don't know what that is, look it up. But essentially, the goal of corner balancing is to make your front left and rear right have a certain weight number that is equal to your front right and rear left. So you have a 50-50 cross weight distribution. This will make the car handle the same when you're going left or going right. To do that, you have to change the corner weight, you either extend or shorten the coilover at that particular corner. When you are doing that and the height on a particular axle is not the same left or right, but your end links are the same length, you are either pushing or pulling on that sway bar or anti-roll bar. And so it's now no longer neutral, and it's exerting a force in one direction or another. And that will change the handling characteristics of the car, even if the car is just sitting static. That's called sway bar preload, and it can introduce either understeer or oversteer depending if you're turning left or right and depending on which bar you got it on. But essentially, it's an unwanted characteristic. So, because you got these different heights at different corners, an adjustable end link will enable you to change the height of the end link such that there is no force or there is no load being exerted by the sway bar, right? So you've got the exact right length so that you're not pushing or you're not pulling on the bar. So that is really, in my opinion, one of the main reasons why you would want an adjustable end link. Okay, so now that we know what an end link is and why we want an adjustable one, how do we make our own? And so the things that we need to think about are, one, the diameter of the bolt, the positioning of the end link in relationship to the control arm and the sway bar, and then the length of the end link. So let's start with the length of the end link. For the 2015 WRX, actually for most of the Subarus, the front end links are very, very short. And so this actually causes a packaging problem. Took a rough measurement and it was about 73 millimeters, give or take. I don't know, it wasn't super accurate, but roughly 73 millimeters. And that's sort of why the length of this end link actually causes packaging problems, because typically what you would see in adjustable end link are two ends and then like a turnbuckle in the middle. And to make it easy on whoever's adjusting the end link, you would simply just loosen two jam nuts, grab this turnbuckle and turn it. And because they're counter threaded, when you turn it one direction, it'll lengthen the end link, and when you turn it the other direction, it'll shorten the end link. And it makes it really easy. You don't have to remove one end of the end link to change its length, which you would have to do in this photo here of the end link that I built for this car. So the packaging problem comes down to this minimum length, right? Or this length, the stock end link length of 73 millimeters. If to create a turnbuckle style end link, you would use two of these, which is a male rod end, and then you would have that tube in the middle. So at bare minimum, the length of the end link would be when you have this rod end or two of these rod ends touching end to end or tip to tip, right? Because it can't get any shorter than that. And most end link manufacturers will give you all sorts of dimensions, and in this particular case it is considered A, right? And so just keep that in mind for now. Chances are for the Subaru, when you put A and A together, it's much longer than the stock end link of 73 millimeters, which is why you can't create a turnbuckle style end link for these cars. So what you have to do is you have to take one of these male ones and use one of these female ones, right? And what will happen is the center is hollowed out and threaded, so the male portion of the rod end will go into the female one, and then there's just kind of this overlap that's occurring, and so this minimum length is now much shorter. And it enables you to shrink the packaging size and hopefully at least get to the stock end link length. Okay, so that's the first thing you got to think about is the length. The second thing you got to think about is the angles of everything in relation to one another. This is going to be trial and error, realistically. Um, the balls inside of these monoballs can only articulate a certain number of degrees, and if everything lines up well, maybe that range of motion will work out well on your car. For the Subaru, because of the angles of the control arm and the sway bar, we need to use misalignment spacers, which um, allow us to take the ball and use a spacer and actually gain a few degrees of articulation or rotation in the monoball. And in fact, it's the sway bar on the Subaru has this really weird curve, and you actually have to use more spacers on both ends so that the drop link isn't at a more extreme angle. So you space it out from the sway bar, and you space it out from the control arm so that it's more vertical and less at a crazy diagonal or steep slope. And the last thing you want to consider is, again, the bolt length or bolt diameter, or diameter of the factory end link. For the Subarus, 15 and onward, they got a slightly thicker roll bar in the front of the car. And Subaru went from a 10 millimeter bolt diameter or 10 millimeter shank diameter to a 12 millimeter shank diameter. And my guess is maybe the sway bar is because the sway bar is stiffer, they wanted a thicker bolt to deal with the additional, I guess, like spring rate or force that it could potentially exert. Okay, so the first one is going to be length, which we can kind of calculate out because we have a bunch of given dimensions. The second one is going to be really trial and error. And then the third one, bolt diameter, we know, and we can, and you'll see why that matters here in a second. All right, guys. So now that we know those three things that we got to look out for. How do we actually choose the right rod ends to help us create these drop links? So the first thing we can do is just look at the bolt diameter, which is 12 millimeters. And naturally, if we just use a rod end that's 12, has a ball that has a diameter of 12, that would be super easy, and that would be like one less thing we have to do to make it work. So any reputable rod end manufacturer like QA1, Aurora, NMB, or FK rod ends, they're going to have these diagrams here that have all these different dimensions. Right, so right off the bat, this is the side profile of the rod end. This is the outer race here, and then this is the ball, and we know that B is representing the ball diameter. Right, so B is diameter, and we can scroll down here, and here are the 12 millimeter diameter balls, or rod ends with 12 millimeter diameter balls. Two different part numbers here. The F indicates it's fine thread, so the stud has a fine thread pitch, and without the F, it's coarse thread. So you can see here M12 by 1.75 versus M12 by 1.25. So, if I was so inclined, these would probably be a good place to start. And the next thing I want to do is start figuring out the minimum or the length. The length of the end link. If I were to put a male version of this, so this one with a female version, right? And they actually have two different dimensions here, so I've got to put them both down. And so I want to go minimum length and maximum length. And minimum length would be if I thread the male version all the way into the female version, or a female rod end, and then maximum length would be if I were to thread the male rod end out while still maintaining a safe thread engagement, what that overall length of the end link would be. So what I've gone and done is I've taken these dimensions and I've copied the diagram and then punched them all into a spreadsheet. And my primary concern is dimension A, which is going to be the distance between the center of the ball to the end of the stud or the shank, and then the shank itself or the stud itself the actual length. So I know that this length is A, this length is C, and this is for the male rod end. And then I've got, I mean, it's the same picture, but different dimensions for the female one. And so to calculate the minimum length, which I've done here, I've taken dimension, C, I'm sorry, A minus C, which gives me this distance here from the ball to where the stud or shank starts. And then what else have I done? So I did that for both the male and the female one. So that's what you see here, A minus C, which is 21, and then A minus C, which is 26. Let's see here. So that's essentially given me this distance, here to here, right? And then I've added the actual shank length or the stud length. So in this case, C would be 33, and then this case, it's a female, don't let this picture fool you. This one is 24. So there's something to consider here is that as I'm threading the male version or the male rod end into the female rod end, this dimension actually changes, right? Because they start to overlap. And because I'm looking at the minimum or the smallest position possible or length possible, it's really going to be this 24, and then this 33 will become 33 minus 24, which is 9, right? Because the stud will go all the way in and only 9 millimeters of thread will be exposed. So that's the math you see here. And what you get is, in its most compact configuration, if I were to use the rod ends with a 12 millimeter diameter ball, my minimum length would be 80 millimeters. And we know that roughly the measurement of the rod ends or the stock end link was 73 millimeters. So right off the bat, we know that unfortunately the 12 millimeter rod end is not going to work, which is a huge bummer. And so that might be the reason why people are not developing or have sold an end link like this for our car. Now, if I just do the math for a 10 millimeter rod end, so again, I've taken all the specs for a 10 millimeter rod end here, and 10 millimeter rod end here, and I do the same math, my minimum length is now 70 millimeters, and that actually falls within the window for the stock end link, right? But here's the thing, is as we corner balance a car, we need to have a range of adjustment. And if we really lower the car, the end link needs to shrink. And 70 millimeters might not be small enough. Now we could do the calculation for an 8 millimeter rod end, or 8 millimeter diameter ball rod end, but it's like a little uncomfortable because we're going from 12 all the way to 8, and you know we're going to make a sacrifice in the load rating or the capability of the ball. So if ideally I want to use the biggest possible rod end I can, right? Can't use a 12. No way I'm going to be able to use a 14 unless I drill out my control arm or drill out my sway bar. So I'm going to try to make a 10 work. And so what I started doing over here was calculating, well, you know, the stud of the male one is sticking out slightly when I have it all the way inserted into the female end. So I can actually start cutting threads off the male shank and reducing the overall package or the overall length of the end link. So that's all the calculations that I did here, and I found that if I were to cut 6 millimeters of thread off the male rod end, I would have this window of adjustment, which would be awesome. So this is all theoretical. This is while I was selecting which rod ends to buy. Turns out they're just fine the way they are. But I went through this exercise just to show you guys in case you guys were kind of looking to do the same thing. All right, so now that we have the rod ends that we want to use, unfortunately they're 10 millimeter rod ends, right? So we've created this problem where we have a control arm and a sway bar that accepts a 12 millimeter bolt. I'm sorry, a 12 millimeter bolt, um, but we're trying to use a 10 millimeter bolt, and we can't just stick a 10 millimeter bolt in that hole. It's and think it's going to be honky dory. So it's not going to work. So we need to create a sleeve that'll sit inside there and take up that space. So what I've done is I've purchased these stainless steel tubes that have an inner diameter of 10 millimeters and an outer diameter of 12 millimeters, and cut them in very small portions, and then actually slip them into the control arm and slip them into the sway bar. Now, I know I'm not like a material engineer or anything like that, but I know stainless steel is really hard and very strong. On top of that, I know that this control arm is aluminum, so the stainless steel is going to be stronger than the aluminum. And then I know that this sway bar is some type of steel, and chances are the stainless steel is going to be stronger than the sway bar itself. Um, One of the things to note here, so as I've having installed this on my car, the fit on the control arm is pretty good. It doesn't wiggle in there or anything like that. Believe it or not, the holes in these sway bars are actually bigger than 10 millimeters. Or 12 millimeters. They're like 12 and a half millimeters. And I've seen this on more than one car. So I think that's kind of normal for these Subaru sway bars. Um, so if you actually take a factory end link off of a car and you stick it into this hole, you'll notice that there's some play in there. I don't know why that is, but in any case, we're going to use the sleeve just because it's probably the right thing to do. But there might be some play in there. The other thing to note is that, because we're using a 10 millimeter bolt, Subaru previously used a 10 millimeter bolt, but when they upped the size of the sway bar, they went to a 12 millimeter bolt. And I'm only guessing here, but I think they did that because the sway bar was stiffer and they didn't want a 10 millimeter bolt to snap, so they used a 12 millimeter one. So I don't know what the bolt grade is, or the grade of the shank is on the factory end link. So I just simply chose the highest grade that I could buy, which is not a grade 10.9 but a 12.9. And unfortunately, these 12.9 bolts just couldn't find them plated. Whether or not that was chrome or zinc or any other type of rust prevention. The only type that I could find was black oxide. And black oxide is a very poor plating. It's not even a plating, or I guess it is a plating for rust prevention, which is why you see the rust that you see here. Bolts are almost a year old and they've held up just fine. After you install them, you could potentially just put some oil on that, and that would help keep the rust from forming. Okay, so that just about covers the bolt diameter and everything that you need for the bolt, getting the bolt into the control arm and sway bar. The last thing is going to be these misalignment spacers here, these two cones, as well as these spacers here. So on the Subaru, the control arm and the sway bar are at very unique or different planes. And that really tends to tweak the end link into some very extreme angles. So one of the things we're going to do here is use these misalignment spacers to help us get a little bit more rotation out of the ball inside the rod end. And then we'll use spacers on the top and the bottom to help offset the end link a little bit to make these angles a little less extreme. Because what we don't want to have happen is have the suspension load in such a way that the balls inside of the rod end run out of articulation, because once that happens, you're just going to end up pulling the ball out of the rod end, or twisting the ball out of the socket. So these spacers and cones are kind of critical. You can buy the cones online here. This is the only place I have found these cones from. They're kind of expensive. They're $6.38 a cone. The spacers that are next to the cones, I purchased from kind of like a off-roading website. Um, they don't actually look like this. They're actually 3 inches long, and I just cut them down to size. Um, Similar to the tubing. Um, I'll post the links here for all of these, and you can buy them on your own. The other thing I'm going to do is I bought a bunch of these cones, and I have leftover material to make spacers, and I have leftover tubing to make sleeves. So I think I'm going to like cut them all up and package them together. That way you guys can just buy them if you are trying to make your own end links, and hopefully that'll help save everyone some money here. Just because I got leftovers that I'm not going to do anything with, and I bought a boatload of these cones, like a lot, because I thought it was going to save some money. It didn't work out right. But okay, I digress. In any case, that is it for the adjustable end links and what you need to make them. In the next video, we're actually going to go out into the garage and take all these spare components that I have, and I'll show you how to actually make a set of these end links and install them. All right, guys, so please don't go buy anything yet. Let's at least show you how to make them and show you what it takes. That way, if it's a project that you want to take on, you can do so. And if it's not, then maybe you haven't wasted any money. Okay, so if you have any questions, please ask in the question or comment section below. As always, thank you very much for watching, and we'll see you at the next one. Take care, guys.